Hello, welcome everybody. You are in the data analytics breakout session. We will get started in about 2 or 3 minutes. We'll give everybody time to transition over, but I can see that people have already joined. So again, welcome. We'll get started in a couple of minutes. Welcome. I see our number continuing to jump up. So welcome to the data analytics breakout. We will get started in a couple minutes. I see the number still climbing quite a bit, so we'll give everybody a little bit of time. Thank you so much. I just wanted to let everybody know that I see in the chat that there were some questions about the AI and ML concentration for computer science. That will be over in the computer science breakout session. So that is for the Master of Computer Science, AI, ML concentration. So I saw some other friends respond and direct people to the other session. Otherwise, you are here today for the data analytics program overview and breakout session. So I'll be talking about the bachelor's program as well as the master's program that has our 3 concentrations in data science, data engineering, and decision process engineering, specifically for data analytics. Okay, I am going to go ahead and get started. It looks like the number has started to slow down a little bit, so I will move forward. And again, welcome. Thank you for being here after the introduction to the School of Technology Open House and joining us for the Data Analytics Breakout. My name is Shay Preem. My pronouns are she, her, and I am the Interim Associate Dean and Director for the Data Analytics Programs. I am joined by my colleague, Spencer Jones, and he will be monitoring the chat and here to support our session today. If you have questions or comments, please feel free to put those in the chat so you don't forget them. We will do Q&A at the end. However, if Spencer is able to answer those questions while I'm going through the session, that's why he's there, and he'll be able to answer some of those questions. Any of the questions that are left over, I will leave time for at the end. All right, so I'm going to go ahead and start by diving a little deeper into the comments from the overview video that you saw a few moments ago. And we're going to start digging into data analytics. Data analytics is truly an umbrella term and discipline that encompasses roles including data scientists, data engineers, analytics product managers, change management agents, and data architects. At WGU, we view analytics as the creative use of data and statistical modeling to tell a compelling story that not only drives strategic action, but also results in business value. Because the term analytics is so broad, there's a lot to unpack. The biggest takeaway is it's not just about data-derived insights. While that's very important and data is critical, it's only part of the whole picture. It's a notion of data analytics being embedded within a business process, and you need to have an understanding of competencies around business influence. Things like communication strategies, change management, truly affecting change, understanding the business domain, and then thinking about where and how you're going to put those insights into a business process to be able to move forward and really make sure that the decision maker has the output of your analysis when it really matters, so then they can act on it. The notion of analytics is cyclical, it's a team sport, and a call to action. When we talk about analytics being cyclical, think about how we evolve over the years. We aren't the same person we were 10 years ago. And as data changes, the analysis you're running needs to fundamentally change too. When we talk about this notion of analytics being a team sport, we recognize how a lot of things have changed in analytics. And it really has become that umbrella where you have roles that include data scientists, but also now include data engineers, analytics translators. Those are people that sit between the business and the technical team that are actually there to be change agents and storytellers. So you have these, again, product managers, data scientists, data engineers, and you have the data analyst, which has really evolved as a role. But all of those people come together to actually form the team of what we consider to be analytics today. And analytics can be anywhere within a business. As you think about your journey, you could go really technical, or you could stay towards some of the business influence skills, or you could find somewhere in between. And you can even change as you go because we really don't know how data analytics will continue to evolve. We just know there will always be data analytics. I want to touch on this last notion of analytics, that is the call to action. Yes, again, the data is important, the model and the algorithms are important, but you need to be able to actually drive change with the results and insights. You need to be able to have a recommendation. There needs to be an actual strategy in place to show and educate how you use what the model output has provided. So all of this together comes back to really form the ingredients to go into the definition that you see here on the screen. And the great thing here is at WGU, in either the undergrad or the master's programs, these are the elements that you will be learning. Now, this quick graph shows you that data analytics exists pretty much in everything we do. Even if you're not quite an analytics professional per se just yet, we are already doing these things. In the first stage on the left, we're identifying opportunities where data can potentially provide value. There are different times in our lives we have a particular problem that we're working at and we're trying to analyze. From our past experiences to be able to make a change or an adjustment to provide a certain outcome. So we have that opportunity identified. At number 2, at the top, we try to transform the data that we have into actionable knowledge using data mining techniques. This might just be trying to put data in a logical order or do some kind of cause and effect analysis, or maybe we're tweaking data in such a way to run a particular type of predictive algorithm. Or you may realize that you are looking at this data. You don't actually have all the data that you need to be able to run a particular analysis in your project. You need to take a step back for a second and put a plan into place for how you're going to collect that data. At number 3 stage, once you have the data and you run some kind of analysis, that's your opportunity to act on it. So what are you going to do? What does your analysis tell you? Are you surprised by these results? Do you have to change the way that the business works or the process flows? What are the implications to this? How much is it going to cost? These are the kinds of questions that you're asking at that stage. This is also where you get those analytics translator roles that come in, where you take the output from the data scientists, from the engineer, from the data analyst, and you start to put it back into a business context. And then finally, with number 4, you need to actually say, if I acted, did the results that I expect actually come to life, or did something different happen? And if something different happened, why was that? Why didn't I assume that that was going to happen? And what was I missing? From the cause and effect of what you did based on the data insights that you derived. And then from there, the cycle restarts itself again. Life changes, people change, data changes, and nothing you build is static. So all of this information comes down to a lot of the different roles that I was talking about. But before I talk about all of those roles, I want to tie some loose ends together. Analytics is ultimately made up of roles that balance three key levers. A lever for programming, skills such as Python, SQL, a lever for mathematical skills such as statistics, probability, and then a lever for business influence skills. Different roles in analytics will have different combinations of these levers. As you're in your analytics career and education, you'll have the opportunity to navigate to the role that best fits your interests and passions, whether it be a data analyst, data scientist, data engineer, machine learning engineer, analytics translator, or some other to-be-defined analytics role that doesn't even exist yet. Our goal here is to build you a foundation that you can springboard from. The data analyst role, which many of you will likely pursue as your first job after graduation from WGU, will have all the levers at the midway mark, meaning that you can demonstrate competitive competence in each of the three skills domains without necessarily being an expert in any of those one areas, at least just yet, until you start to navigate and adjust some of those levers. The role of the data scientist, noted in green, is one where all three levers are moved all the way up. This means that to be a data scientist, you need to have expert level skills in math, in programming, and in business, which is why data scientist roles are seen as a little bit unicorn positions and why they tend to pay so well. The data engineer will have high coding skills and moderate math and business skills. The analytics translator or visualization scientist roles will be higher on the business influence lever skills. There are a variety of opportunities for you when it comes from pathing and flexibility and learning and adjusting those levers as you go through not only your academic time, but also through your career as well. The next couple of slides that are here are really around, is a career in analytics worth the investment? And the great thing about this is that job postings in the analytics field for both bachelor's and master degree holders are seeing tremendous growth, which has been pretty well sustained over the years. Data scientists are among the top 10 fastest growing occupations, according to the U.S. Bureau of Labor and Statistics. And we can see that data scientist roles are in double-digit growth and at or just below six-figure wages. I always really like to point out that the U.S. Bureau of Labor and Statistics, they classify their jobs in buckets. So when this says data scientist here from the U.S. Bureau of Labor and Statistics, it's really bucketing a lot of those job roles that I was talking about a minute ago. So it's not necessarily saying just our three high lever data scientist people are in this bucket. It's actually putting everybody from our data analysts, our data scientists, our data engineers, our analytics product translators. It's really bucketing all of those roles into this. So I would just like to caveat that again, the occupation is a bucket. It's not one of the roles that I was just talking about a second ago. The next part here is that you will see lots of companies are employing analytics professionals today, ranging from companies like Deloitte, Blue Cross, Humana, Travelers. I'm calling out a lot of larger companies, but there are companies of all sizes and organizations hiring data analytics roles today. So if there's a particular area that you're interested in, whether it's healthcare, finance, tech, nonprofit, there's a very good chance that they're hiring analytics professionals in a number of organizations and a number of sizes of organizations. Next, we will review the skills alignment. One of the things that you will see in both the undergrad program and in the grad program is this concept of a data analytics lifecycle, which is really the analytics lifecycle that goes from your business problem and business understanding all the way through the model, build, and getting back to some kind of reporting and visualization at the end. Now, again, in the undergrad, it's really giving you a foundation, and we'll talk about that more in a moment. Yet in the master's program, you'll go deeper into the life cycle. You're becoming more of an expert in each of these different categories. But the thing that's interesting is as you go around the circle, you can see where a lot of those different roles that make this more of a business process can start to come to life. So as we go around the circle, you'll have that business understanding up front. This is where a lot more of those soft skills are going to come in. This is the problem solving stage, and being able to work with your stakeholders as true business partners is where this process gets going. From there, you're going to start to translate that into data analytics problem statements. So you'll be able to work with data at that point. You can create your data wish list, and you may be getting that data yourself, or you may be working with a team to help get that. You'll see skills around database management and tools and languages like SQL, Python, R. There are different ways to get the data and to wrangle it. You'll clean it in the next step. And that is really about getting that adequate level of data where you can run an analysis that you will have confidence in. Next, you'll start to explore that data. Once you have it, again, you may use tools and languages like SQL or Python or R. And this is where you're going to see some of the traditional exploratory data analysis. You're really trying to dive into the data and go back and ask those business questions. A lot of those questions I proposed before. You're going to really figure out where things don't make sense. You may want to make sure that you're immersing yourself and you're not making any assumptions about what that data represents. You'll then go into predictive modeling of some kind, depending what you're working on, what you're doing. Data mining and machine learning are where you'll see some of those more advanced programming techniques come out. And again, you may be in Python or R or something, a different language or different tool. Then you'll finally go back into the acting and learning stage, and you'll be looking at that 11 o'clock hour circle in the top left. This is where you have the implementation and visualization. You'll have tools like Tableau and Power BI that are used for storytelling to drive change management, process engineering, and helping the business to consume what you found and what you predicted and what you built to be able to really affect change. And then it's a life cycle. So we start all over again. Just like in the last cycle flow that I showed you, our business problems evolve, the data evolves, new complexities happen, and we continue to do this life cycle as a living, breathing thing. Okay, I told you that there was a lot to unpack. I'm just going to give that a second to sink in before I start to transition to talk about our programs. I'm going to start with talking about the bachelor's program in data analytics. We refer to it often as BSDA. And again, this is really where you'll get that foundational skill set you need to springboard your career. It's meant to prepare you for a career as a data analyst or somebody who is junior on a data science team, or as a business professional who wants to specialize in analytics. You will see that the program balances those three levers of math, programming, and business influence skills. As you can see, you get a really nice breadth of those different levers. And this curriculum will cover the data analytics lifecycle. You will see languages like Python and R. You will have exposure to statistics, predictive modeling foundations. You'll get data management with SQL. You'll get visualization tools like Tableau, and you'll get exposure to machine learning, especially with the Udacity Nano degree that's offered in the program. You'll see here on the right a list of embedded certifications that you can earn as you go through the degree program. You will see that you have exposure to CompTIA. You will also have, again, the Udacity Nano degree, which is a data analytics specialization. And we also offer the optionality for business influence certification in design thinking, as well as change management. So if you're really interested in kind of those levers where your career starts to take you more to that business side, you can add those certificates as we provide those optional certs with free vouchers. To wrap up, BSDA gives you exposure to the levers and to the different elements of the life cycle. All of this will help you find your passion in what really matters to you and really energizes you when it comes to data analytics. Last August, we welcomed our first round of students into our redeveloped and reimagined MSDA program. We went from one general MSDA program to 3 concentrations. So now we have essentially 3 programs, one that drives you to data science concentration or data engineering, or what we are calling decision process engineering. The MSDA, or Master in Data Analytics, is where you're going to get a much deeper dive into that data analytics lifecycle. And it allows you to establish more of an expertise and mastery of those skill sets, especially as you've picked that concentration that you're going for. You will really go deeper into each of the steps in the life cycle, whether it's sourcing data, mining data, doing your descriptive or predictive analysis, analyzing your visualization, and ultimately putting it all together in your capstone. So with this program, you'll also have exposure to Python and R, and you will get a good focus on statistics from parametric and non-parametric testing. You'll see SQL, database management, data cleaning. You'll have access to Tableau and data presentation. You'll have advanced analytics techniques that will go a little bit deeper than what you would do in an undergrad. You'll have neural networks and market basket analysis. You'll have natural language processing. You'll see some dimensionality reduction, and you'll get a really nice suite of products to be able to use based on the different business problems that you're going to come across. Our goal is to provide you with the mastery of core skills. Think of that data analytics lifecycle and the skills mentioned a moment ago that anyone under the data analytics umbrella needs to be successful. So all of our programs start with the same 7 core courses. If you look at the program guide side by side, all 3 concentration programs start with the same 7 core courses that emulate that life cycle and really represent those different parts of not only the levers, but again, also the different phases of that life cycle. And then as you determine which path appeals to you, or have determined as you pick your concentration at time of enrollment, then you'll start to navigate into courses that are related to those concentrations. And again, think about those levers. If you want to be more on the data science side, because machine learning, the natural language processing, some of the high levers, you really like the coding, you really like the math, and you really want to know those business sides, that data science concentration is going to be the best. Data engineering, just like our data engineering roles, maybe the business influence isn't as exciting to you. You're still going to get those foundational core skills. However, you really want to focus on the scaling of the data processing, the cloud parts of data. That concentration degree is going to be best for you. And then with the decision process engineering, think about that lever. If you want to be somebody that's in between, that talks the talk, maybe you have a lot more of those business skills and you really want to hone in on your coding and statistics and stay in that realm with the business influence and be that conduit, that concentration is going to be the best direction for you. Just like in the undergrad, there are embedded credentials. You can see here on the left-hand side, every new student will receive 3 internal WGU certificates, 2 from the core. So sorry about that. And there will be 1 for data operations and data preparation professional. And then you'll get a specialization embedded certificate for your concentration as well. So again, those core 7 courses have the same embedded certificate. And then once you get into your specialization, you will get that 3rd embedded certificate. And one of the things that I love about those, whether you're in the undergrad or in the master's program, is that you can get those on your LinkedIn, get them on your resume to get people excited about what you're accomplishing as you work through your program. So I kind of used the language earn as you learn before in the last slide. That same philosophy is applicable here too. So you can start to show those certificates and certifications that you're earning and start applying for some of those jobs. You don't have to wait until the end of your program to start showing what you've accomplished and what you've earned. I love that about WGU. I am just going to end on an important note for the master's program on the expectations of entrance and success for these master's programs is having that foundational knowledge of statistics and programming. You can see that in the admissions requirements. You can also talk to an enrollment counselor if you have more questions, but it is really important that before you come into the master's program that you have foundational knowledge of statistics and programming, and we have ways to help you do that. So if that is something that you're feeling a little bit nervous about, meeting those admissions requirements, talk to an enrollment counselor. We have lots of ways to help you get those skills before day 1 of your course starts. Yeah, that is most of what I have for the 2 programs. But before we move into questions, I'm just going to do a really quick recap. So the bachelor's program, again, is really about exposure to the foundations of data analytics. It's really about the breadth of information that's covered. And you're learning about the data analytics discipline generally, learning most of the important skills to get you started or to switch your career. Where the master's program is really about depth. It's about diving into the statistical analysis, programming, machine learning models, and advanced data management. In our programs, you will walk away with the ability to break down and think through analytics problems. And once you're employed, you'll be able to apply that thinking and helping to navigate analytical problems as you work to, again, effect change. All right, we can move into questions now. Spencer, do you want, I don't know, hopefully you've been tracking some questions. So if you want to come off mute, if there are some questions that you know that I can try to answer, I can do that. And I do recognize that we are at time, I think, right now. So if people have the availability to stay behind, I have the availability to stay behind to answer some of these questions. And again, I think that everything will be wrapped up and shared, or if you have any additional questions, best option is to always reach out to an enrollment counselor as well. You can always find me on LinkedIn. I'm happy to answer any questions that way as well. Your enrollment counselor will be really helpful as well. So just want to make sure I got that caveat in case people have to move to a call with somebody else or a meeting. So I just wanted to make sure that that's there, but we can officially move to questions, Spencer.
Yes, so there are a couple questions that are in the chat. One to highlight in particular is about the programming skills that are needed before going into the MSDA program.
Mm-hmm.
Do we have, I know that there's some information regarding our admissions process. Do you happen to have a little bit more information that could be provided?
I can. So what we're really looking for when it comes to programming is this understanding of what is called algorithmic thinking. So really being able to understand how to break down questions, think through them, and then apply tools. So if you've ever had experience in SQL, Python, R, even if you've had experience in older programming languages like SAS, that can help you be prepared and get ready. We have a course at WGU Academy that is called Foundations of Coding, and it does just that. So it is a course that can be done. I think it's about 5 to 6 months, because that's really what we recommend, is about 5 to 6 months of true understanding of skills, whether that be in SQL, Python, or R. And so again, you've got SQL, that's going to be more of the language from the query language versus a programming language. There's some similarities, but there are also some differences. But having an understanding of how that works, one of the biggest tips that I always give too is, with programming, you need to know that it's okay to fail. I think sometimes in society, we're like, we have to get it right the first time. It has to be done. We can't do it again. And you have to kind of throw that out the window when it comes to tech and to programming, because your models are probably going to fail. You're going to have bugs, and then you're going to have to go and fix them. And that's okay. That's going to happen. And we all sometimes have to just get out of our own way to say, no perfection. We're learning, and we're evolving and changing those, that code as we go through. So, I hope that helped. That was a very long-winded answer that I was kind of hoping I might be able to answer a handful of different questions that come up at the same time with those questions. But really what we're looking for is 5 to 6 months of skills in SQL, database management, and a programming language. We use Python and R in our programs, so it's best if you have at least one of those. You will have the opportunity to learn both in the program, but if you specialize and focus on learning those foundational programming skills ahead of time, that's what will meet the admissions requirements, as well as ensure that you're prepared for the actual program so that you can pace and meet your graduation goals and things like that. I hope that answers that question. My best advice, if you still have additional questions, is to check out the WGU Academy Foundations of Coding course. That will highlight what we have identified as the best tools, the best skills, and what you would learn about, again, algorithmic thinking, troubleshooting, and those tools languages that I've shared.
All right. We do have a couple questions regarding AI.
Okay.
We might be able to touch on them both at the same time. The first question is, how much of an impact is AI going to have on the different concentrations? And a concern about AI replacing entry-level data analyst roles.
Yeah. I can talk a little bit about where our programs are. I know that there are a handful of questions. WGU does have a lot of different programs that talk about AI, machine learning. So I know some people were asking about the brand new Masters of Computer Science AI ML program that is within the School of Technology. So really, what we do is AI is foundational to the large language models and the pieces that come from this larger scope of what AI really is. And that is foundational in data analytics. So that is covered across our core skills, whether you're in the undergrad program or in the master's program. But if machine learning, large language models is something that you're really interested in, I would highly recommend that the data science program is the one that you pick. That's the one that's going to really focus on those core skills and mastering those skills. So again, you've got your core skills, which will be touched on in a variety of courses, whether you're in the bachelor's program. Again, a lot of the AI skills will be taught in towards the end of the program as part of the Udacity Nano degree, where you have an intro to data science course, a machine learning course. There's another advanced analytics course in there as well. But then in the master's program, again, you will see that throughout those throughout the core skill courses. And then again, if that AI excites you the most, your best bet is to go into the data science concentration. And again, it will continue to leverage that data scientist perspective. So we've got all of these wonderful programs in the School of Technology, but the way that we build programs is there's a lot of overlap in courses, but which job title do you want? So there might be overlap in what you're learning across the programs, but what we do is we take the skills, align them to competencies, and align them to job titles. So we have kind of taken this spider leg of bringing it into courses that are related to data science, where again, there's going to be an overlap of skills in AI that may be in other programs, but they're driving you to specific job titles. I hope that helps. As far as the concern about AI replacing tech jobs in general, whether entry level or anything, we're all figuring that out as we go. I think the biggest thing is that we still have humans in the loop. There still have to be people that are doing the work, and we still have to have people that are checking models, that are checking code. And that's really what we're still trying to do, and what we are doing with our courses and our programs is to ensure that we have skills that are longer than some of the different trends and things that we're seeing now. So we're trying to, again, build those foundational skills that evolve and change with the changing role of technology and roles that are out there as well. So even in the presentation I talked about, we don't even know what some of the roles are going to be in the future, yet these skills are foundational to how we work with inside of businesses and how we continue to bridge the gap on data analytics insights and affecting change and really making progress at organizations and institutions. So that's really what we're doing here, is providing those skills that can outlast.
All right, and then just to just since we are a little bit
Yeah.
over, we don't want to take up too much more time.
Yep.
I know that there was a question about how students are tested that I replied to in chat for you,
Great.
Brandon. But we do have one other, which I'm actually kind of curious on. Are there any certifications someone should pursue for the MSDA program to help build skills in Python, SQL, and R?
Yeah, so there is another web page. I didn't prep you probably for this one, Spencer, but if you go to transfer, you might have to just Google like Transfer Partners WGU. There's a whole page there. that will show you different certifications that you can get that actually even help you transfer in courses once you have been enrolled into a program. But really why I want to call those out is it allows you to see different AWS, different Oracle, different industry leading certificates that you can gain that can be leveraged to help you in your program. But also, as far as gaining anything beforehand, we do have the course that provides a certificate from WGU Academy that can help you get some of the foundational skills. So it really depends on if you're trying to get foundational skills or industry-led certifications that emphasize a tool or a technique or a process. Some of those you will have to have foundational skills for ahead of time, but depending on where you are in your career, if you've already been in tech for a while, there are definitely some certifications that are in there that you can stack and gain to help you progress through your program. But my recommendation is to take a peek at the transfer page or ask your enrollment counselor. They can direct you to get an enrollment counselor if you don't have one yet, and then they can help direct you to kind of what that transfer page looks like and what some of those certificates are. Okay, I know we're over time, 12 minutes, so I just want to say thank you, everybody, for joining today. I really appreciate you. I really appreciate your time. Spencer, thank you so much for help in the chat. And again, any further questions, reach out to an enrollment counselor, or like I said, reach out to me on LinkedIn. All right. Thanks, everybody.